Mathematically, when we use an internal standard, what we're interested in is what's known as the response factor. And this is the ratio. So if we take our signal from our analyte divided by the concentration of the analyte, we want that should be equal to some constant, which we call the response factor F, times the same ratio for our standard. So the signal of the standard divided by the concentration of the standard. So the whole point is that these should be proportional to each other for the analyte and standard. That is the idea behind the internal standard. And there is some factor, either the signal from the standard is going to be stronger or weaker. F can be bigger or smaller than 1. And so we can rewrite this as our signal. We'll call the signal A. This is the notation used in your textbook. A of x divided by the concentration of x is equal to the response factor times A for the standard divided by the concentration of the standard. Right, and remember the internal standard here is a different chemical from the one we're trying to measure. So X and S are different. And then the idea is similar to with standard addition. We will usually construct a calibration curve rather than just using. You can do this with just one point and find the response factor. If we know the response factor already and we measure the signal from our analyte, the signal from our standard, and we know the concentration of our standard because it's a standard, if this is known, then we have everything we need and we can find X, right? This is our only unknown. Now, you can do this with just one sample, but generally what we do is that we use multiple concentrations of known standard and known analyte to construct a calibration curve. All right, so your calibration curve will look something like this. We have here the ratio of the signals, and on the x-axis we have the ratio of the concentrations. This should fit to a line, and the slope will be equal to our response factor. And then once we know the response factor, if we measure the signal from the analyte as well as the signal from the standard and know the concentration of the standard, we can use this formula that we have written here to be able to find the concentration of our unknown that we want. Okay, so that concludes Chapter 5 and our options for doing calibration. Remember, now we have 3 different options. We have our typical calibration curve where we prepare solutions with known concentrations and find the signal from those and construct a line. Then we measure our sample and see where it fits in that calibration curve. Our other option, when matrix effects are important, we need to do a standard addition where we can keep the matrix roughly the same for our standards that we're preparing as in comparison to our sample. So that's when we'll need to do something like that. And then we have this final option of internal standards where we can't control the conditions of our experimental technique very well, and we need something in there that will sort of track along with our analyte. And anything that will happen to the analyte also happens to the standard, and so it's the ratio that matters rather than the absolute values of the signals that we get.